In 2.7, we are going to discuss filtration. So when we do a gravimetric analysis lab, the mass of product from a reaction is measured to determine how much was present. So most precipitates are collected in a fritted glass funnel, also called a Gooch filter crucible, with suction applied to expedite filtration. So that means that you'll have your Erlenmeyer, and then that's going to be connected to a water suction filtration, followed by your rubber stopper, and then on top is going to be a small fritted glass crucible, and it'll collect your compound here. Glass crucibles with different pore sizes are available depending on coarse, medium, and fine. Of course, the more fine it is, the more expensive it is, and you want to have the specific size for what you're trying to recover. So the first thing you need to do is clean empty crucibles. To get a clean empty crucible that is dried to 110 degrees Celsius using an oven or a microwave oven, because we want to make sure when you weigh it, it's as accurate as possible, and we don't want any water from the air absorbing onto that glass. After drying, the filtering crucible is removed from the oven and placed in a desiccator to cool before obtaining its mass, because the temperature will affect your weight. After collecting solid, the crucible and its contents are then dried again before cooling and obtaining a mass. So you'll be like doing water filtration, like you'll be putting it on top of that crucible and it'll be wet. So once you've done the suction filtration, you'll put it back into an oven to dry for a certain period of time. Once it's dried, you'll let it cool and then weigh it again. Then you will measure the difference between the two masses, representing the mass of the solid collected. And then the liquid, which a substance precipitates or crystallizes, is called the mother liquor, and then the liquid that passes through the filter is called the filtrate. So remember that here's your crucible, and then here is your rubber stopper, and then your Erlenmeyer connected to a water filtration system. The solution that you are pouring over it is your mother liquor, and then the solution that's being filtered out is your filtrate. Here is a better picture of a Gooch crucible, since this is usually white and it's very, very porous, even though it doesn't really look like that. You'll have a rubber stopper to make sure the seal is good, and then you'll have the suction flask. In some gravimetric procedures, the sample is ignited or heated at a high temperature over a burner or furnace in order to convert the precipitate to a known constant composition. But most of the time in our labs, we just use ice or another way to get the precipitate to form. If we don't have crucibles, we can also use filter paper to collect solids. So filter paper and a glass funnel can also be used to physically separate a solid from the mother liquor. It's just a much slower process. So you'll have to fold the paper in half and then fold it in half again. Tear off a corner to allow better seating in the funnel, and then open the side that was not torn and place in the funnel. And then after placing the filter paper in the funnel, set it using distilled water. So what that means is you want the filter paper to be on the sides of the funnel, so when you pour your mother liquor in, it doesn't make a mess or go into the wrong part. So you add a little bit of DI water to get it to stick to the glass. And then the slurry of precipitate, which is in here, is poured down a glass rod into the glass funnel containing the filter. Particles sticking to the glass can be removed using a rubber policeman. Use a wash bottle to transfer any remaining solid to the filter. So once you've poured it out, anything left on the insides here, you can just use a DI water wash bottle and just rinse it several times and into the filter paper. The precipitate should settle in the beaker before starting the filtration. And then do not allow the water level to go over the top of the filter paper, or then you won't be collecting everything.